In this lecture, I would like to outline the main aspect of the new chemical species of MagneGas, namely clusters composed by ordinary atoms, dimers, or molecules that are bonded together by a force of primary magnetic character. My presentation will be primarily intended to illustrate the environmental possibility and advantages in the use of fuel with a molecular structure for the automotive industry as well as for the aerospace industry. I should indicate that I initiated the studies in early 1980s when I was at Harvard University on the DOE support. And the reason for such a long period of time prior to publishing the first paper is due to the existence of three really substantial technical problems that had to be overcome and resolved prior to the release of any publication in the field. Needless to say, my presentation will be grossly insufficient due to lack of time, but I remain available to correspond by email with any interested colleague or have any Zoom session to enter in more technical detail. Remain also available to interested colleagues for writing a joint paper on some of the many numerous and some of it very intriguing open problems in this new field of chemistry. I have to report initiated with the following question when I was at Harvard University in 1980. Let us define as a chemical species a collection of atoms which are bonded together with an internal attractive force. Collection of atoms bonded together with an internal attractive force. The question which I raised at Harvard was the following. Is the conventional chemical species of molecule the only chemical species existing in nature? The almost unanimous answer by colleague was no. And the reason is evident because there exist many clusters, if you want, or collection of atoms bonded together in nature. Was chemical structure, chemical features mostly unknown at this moment or debate under scrutiny and scientific process. Let us begin by observing ordinary liquid water. What is the evidence? The evidence is that, first of all, the molecules are kept together by bond. So to reach a sufficiently deep understanding of nature, we have to achieve a numerical representation of the attractive character of the bond between the water molecule to reach a sufficiently deep representation of nature. So we were looking what is this force. The second aspect, which is known from our infancy, namely that water boils at the boiling temperature, 100 degrees centigrade, the liquid state of water ceases to exist, and we have a transition of state. But then, ladies and gentlemen, this immediately gave us the suspicion that perhaps the bond between the water molecule in their liquid state is of magnetic character, or at least a magnetic component should exist, because then the 100 degrees centigrade will be a very natural Curie temperature of the liquid state of water. The suspicion of a magnetic component in the liquid state of water was soon confirmed by just an inspection of the conventionally accepted structure of the water molecule, which is depicted here. As you can see, the two hydrogen atoms, they are bonded to the oxygen. They are not in their conventional spherical distribution. No, they have to have necessarily a toroidal distribution to reach a stable bond with the corresponding valence electron of the oxygen. But then the moment you see this toroidal character, you immediately see that this hydrogen atom, they have a natural force that doesn't exist in their isolated state, namely a magnetic force of north-south distributed along the symmetry axis of the hydrogen atom. The moment we identified this, it was then immediately consequential to see, but then two hydrogen atoms of two different water molecules, they can attract each other by opposing magnetic polarity. Yes, and this bond is stable at ordinary temperature. Yes, indeed. There's no reason to disconnect it. However, at the Curie temperature, it will disappear because of the excitation of the water. Also because the bond is very weak compared to valence bond. Molecular bonds are very weak compared to valence bond. Once we reach this understanding, then this is what is now called the molecular model of the liquid state of water, in which there is a sequence of water molecules bonded together, and the representation, the chemical representation of this bond is depicted here. We represent the molecular bond with the product. The dash represents, as we all know, the valence bond. Then you can see here the two hydrogen atoms bonded together by opposing magnetic polarity, and the same is for the following hydrogen. Also, you have a chain of this structure. At least it's an initial model of the liquid state in which we have an explicit and concrete attractive force, without which I am lost. I have to see an attractive force to believe in a chemical species. Notice this, I published a paper on this model only in 2016, I believe, so 3 or 4 decades after the conception of this species. From this simple observation, I expressed my main hypothesis, named the hypothesis of a magnecule. What is a magnecule? Magnecule is a cluster. It's stable at ordinary ambient temperature. A cluster composed by ordinary isolated atoms such as hydrogen, carbon, and oxygen, plus the conventional dimer OH, CH, etc., plus ordinary molecules CO, CO2, H2O, etc., which are bonded together by opposing magnetic polarity of the toroidal polarization of at least some of their peripheral atoms. This was formulated in 1998 for the first time, and then the systematic treatment was presented in this 2001 monograph by the distinguished Springer and Nature publisher house. Here I present what we call the elementary magnecule, which is based by two atoms with toroidal polarization, and then they attract each other, and apparently they remain stable. Now, of course, the most elementary magnecule will be that by two hydrogen atoms. Then this is what we call the three-body magnecule, or the simplest version being that of the hydrogen. And now the H3 is only one state according to quantum chemistry. For us, H3 is a combination of two possible states. Still, we don't know the percentage of which, but because it composed first, the three hydrogen atoms can bond to each other in this fashion, or a conventional hydrogen molecule can be polarized in such a way that they will attract a polarized hydrogen atom, therefore reaching also an H3. Now, here below you can see what we represent conventionally to be a gas with molecular structure. As we will see experimentally very soon, it is given by a collection of molecule all the way from 2 atomic mass unit all the way to 400. We have measured even up to 450 AMU. Of course, in the percentage, in a very, very small percentage, the biggest percentage being those at the low level up to 4 molecular structure could be achieved, subject to verification, via the use of a submerged DC electric arc. The first idea is, of course, to have this submerged electric arcs within a gas itself, so as to convert it from a molecular to a molecular structure. However, we discovered that it was much more efficient to use a submerged gas under certain technical conditions that we will indicate briefly. But we discovered that it was much more effective to use a DC electric arc submerged within a liquid. According to a reactor, which is indicated here, essentially is a metal vessel filled up with a liquid that you select, water, crude oil, or other liquid that you intend to gasify. And inside this, within this reactor, there is a pair of electrodes with one stationary, the other movable, and the gap is controllable remotely from the outside. And this DC power, the AC-DC converter, providing the power to the two electrodes. The process is called plasma arc flow, because the liquid is continuously recycled through the arc. You see, there is a pump here and recycles the liquid through the arc. What happened is essentially the following. DC arc between carbon electrodes are not continuous as it may appear to our eyes, because when you look at them at the level of millisecond, you see that the DC arc is activated to the two closest points of the arc. Those points are consumed, so the arc disconnects itself and then reconnects in another pair of points, which are the closest possible within the electrode set. Conclusion, the arc is made up of a continuous sequence of connection and disconnection of the DC arc. During the connection, the liquid is essentially bombarded by millions and millions of electrons of the DC arc, and therefore the liquid is totally separated and reduced to individual atoms, or sometimes the atoms themselves are ionized. So there is the creation of a plasma at a very high temperature, usually in the range of 15,000 degrees. Then, under the condition we'll indicate in a moment, the magnetic field of the DC arc essentially controls the distribution of the valence electrons and reduce them from a spherical to a toroidal form, but therefore naturally aligning the atom with opposing polarity along one of the magnetic force line. When the arc disconnects, then there is something very mysterious, still basically unknown, namely the plasma is compressed toward the actual symmetry of the arc itself, for a technical reason that I do not know, maybe appears to be connected to the Ampere law. But where the effect is true, so the polarized atoms are compressed together, but therefore end up forming molecule. There is, however, a threshold below which the molecules are not created. This is a problem that was solved by Professor Askar Aringazin from Kazakhstan and from Almaty University. And he essentially established that the toroidal polarization, such as this one depicted in this view, is achieved if and only if the magnetic field, or if you want the DC, the current, or if you want the power, has a certain minimal value. Below that value, molecules do not exist, are not created. It is a point in which a number of companies have attempted to duplicate the process and failed to do so they did not consult me, so I'm sorry for them. This was the original conception of a gas with molecular structure. The fuel was originally called aqua fuel by designation, by the request of the engineer Leon Tubbs, that of course I did honor, and I used the name aqua fuel in my publication of the time. However, subsequent study indicated that indicated that a much more efficient process is depicted here. It was also called plasma arc flow, but in this case the liquid is flown through a hole in the electrodes, and then comes out of the arc itself. By therefore, in this way, the liquid is forced to pass. There's no portion of the liquid that can escape passing through the arc, a feature which does not exist here because, as you can see, this is flown from the side. So some of the liquid will go through the gap, but other will not. And so therefore, the efficiency of this second is evident. I cannot enter in more details. Here I list 3 of about 12 or so US patents I obtained in this process. They have an accurate description that those of you are interested. But anybody or everybody is interested in duplicating the process without consulting me for advice, then they should look at those patents to avoid wasting considerable volume of funds. Here I would like to show a few pictures of MagneGas refinery. The second process was called MagneGas because we started to identify a variety of fuel, all with the same general feature, but having, however, energy content, different purity. It's evident that MagneGas produced from water is very pure and has a limited amount of power, but the MagneGas produced from crude oil is, of course, not as pure as that from water, but it has very high energy content. This is a small 50 kilowatt MagneGas refinery, which can be transported on a trailer, can be transported by an SUV. This is a reactor that we shipped to Kazakhstan and has been operated. It still is in the hands of Professor Ringas in Kazakhstan. Those are stationary refinery. This is 150 kilowatt here. This is 200 kilowatt, if I remember well. This is a 300 kilowatt refinery in two trailers, one for the main operation and the other for all the service, cooling of the liquid, compression, etc. Here you see the view of the reactor. You see the tower that produces the MagneGas is at the center. On the right hand side, you see 6 50 kilowatt AC/DC converters. So this unit can be used from 50 kilowatt all the way to 300 kilowatt. This is a MagneGas refinery we shipped to China, and this is the biggest I have ever built. It was half a million watts. Those new machines were produced by MagneGas Corporation, a publicly traded American company, US company that was traded at NASDAQ, and was where I developed most of this technology, as well as most of the knowledge of the MagneGas. Molecular fuel was developed at MagneGas Corporation. I would like to review now what turned out to be the most difficult aspect of our entire studies on the new chemical species of molecule, which was given by their experimental detection. The primary reason for this difficulty that lasted for 2 decades, essentially, is the following: that molecules have a very strong binding energy. I've recalled a number of times that the tiny puny hydrogen atoms can bond together into the hydrogen molecule with an incredible amount of 110,000 kilocalories per mole. In view of this very strong binding energy, then the detection of molecules is relatively easy. Why so? Because the detection equipment can use a significant ionization energy. So the molecules are bombarded with a rather strong beam of electrons that's sufficient that will ionize them, and so as to render the detection much more easier. All the equipment that are so efficient for the detection of molecules are inapplicable for molecule, and that was the difficulty. Why so? Because when they are used at the ionization energy, which is so efficient and so valid for molecule, that ionization energy will destroy the very species to be detected. In other words, the equipment destroyed the species that was supposed to detect. So it took years finally to locate not only an equipment, but also a laboratory in the United States of America that was sufficiently receptive to novelty to conduct analysis in a very rather unconventional way as far as the preceding history of detecting molecule was concerned. Well, in this first slide, I present a very familiar equipment. I'm sure all of you know. On the left, there is a GCMS, and on the right, there is an IRD, an infrared detector. Those two instruments are generally used in conventional, in contemporary analytic laboratory in a separate way. The reason being because once the molecular content of a species has been detected with the GC, it is established, and there is no doubt. So therefore, the IRD can be used separately from the GCMS. Now, the novelty that finally, in the use of those two instruments, that finally initiated the experimental detection of MagneGas was that we requested the joint use of the two equipment, so that exactly the same sample of gas had to be detected first under the mass spectrum, and then exactly the same sample under the infrared detector. That's when the novelty, structural novelty, finally emerged. But that was only the beginning, because in order for the GCMS, which has been designed, conceived, and works so beautiful for molecule, to get any information, even a preliminary information out of a GCMS, that equipment had to be used in a very unusual way. For instance, here there is some of them. For instance, the feeding line has to be cryogenically cooled. Remember, MagneGas die with the temperature. They are stable at ambient temperature, but they die with increase of temperature. There is loss of actual species in the sample, and also the column has to be, the entire equipment has to operate. The column has to be at ambient temperature. If you use the column as it is in contemporary GCMS, the column is very high temperature. Ladies and gentlemen, don't try, because whatever, sure, it will detect it, but the instrument again will destroy the species that you're supposed to detect. And another unusual request is that the ramp time has to be the longest possible. The test that we did were 25 minutes of ramp time. This is the total nonsense for contemporary analytic laboratory, because now all the equipment have been designed to give a virtually instantaneous response. So we're talking about ramp time, very, very short ramp time. So when we were asking for 25 minutes ramp time, we had a very, very uncooperative response. Well, so in any case, we didn't give up. I didn't give up. So I started looking for all over America a qualified analytic laboratory that was equipped with the GCMS I/IRD, namely GCMS, which is completed by an infrared detector. And succeeded in locating this instrument at the McClellan Air Force Base near Sacramento, California, and in particular at the laboratory, analytic laboratory located in that Air Force Base is called National Technical System, NTS. And the first detection of MagneGas occurred indeed in June 1998. What happened is essentially the following: has been reported in all detail in this 105 pages memoir, which is the first release under my signature even on the word, the first appearance of the word, new chemical species of MagneGas, dated 1998. Well, the inception was in 1980. We're talking about close to two decades, precisely because of the difficulty in the detection. Well, we were very lucky that the laboratory, the head of the analytic laboratory, Dr. D, he's a scientist and not just an analyst. So he was receptive at the use of the GCMS with the very unusual way that we indicated before. And so finally we started testing a sample, a small bottle of a MagneGas. In that case was called aqua fuel. We'll indicate soon why. So this sample was injected in the through cryogenically cooled feeding line, and all the requirements were followed by Dr. D. And then finally the instruments, after 25 minutes, produced this magnificent mass spectrum of aqua fuel that the instrument had been selected from 40 atomic mass units all the way to 500. So when Dr. D and the other analysts saw this magnificent mass spectrum, they became suspicious. And they said, Ruggero, are you sure that the gas that you produce was produced by submerged electric arc between carbon electrodes in ordinary water? In this case, the heaviest molecule that was predicted is CO2. And so they started to question me. This I don't see the CO2. They should appear here right away, but it didn't. So there was a moment of tension in which they tried in the laboratory. They start to question that I told them the truth, that the gas had been produced in the indicated way, carbon electrodes, a DC electric arc between carbon electrodes submerged in ordinary water. Well, but then I told them, listen, I'm here because you have a GCMS equipped with IRD. So please, let's complete the analysis. I understand and respect your legitimate doubt, but it's a species that we don't know at this moment. So please analyze exactly the same species under the IRS. That's why Dr. D was a scientist and not just an analyst, and he was curious, and he said, yes, they did. And the moment this IRD appeared, there was, in Italian, we would say putiferio, namely a big commotion in the laboratory. All the analysts came from all corners and to look at what happened. And why? Because if this series of peaks had been made by molecule, there should have been a series of a signature under the infrared detector. While there was here only one signature, that of CO2, because IRD, like the mass spectrum, had been cut from 40 atomic mass units. So 44 was the CO2. Once they saw this, they immediately started to sense that indeed they were facing, that I told them the truth, that we were talking about a new species. And they, of course, they were suspicious, they requested that we did exactly the same test, no change. Exactly the same test, same duration of runtime, cooling, cryogenic cooling, everything was repeated identically, if I remember, at least 3 times. All times, the results was the same. Namely, on the infrared signature, there was only one. So there was only one, among all those mass spectra, there was only one molecule, which of course, as we will see, is maybe a component of each of them. But the mass spectrum, keep in mind that the CO2 doesn't appear in the mass spectrum. So because it's part of a bigger spectrum. After repeating this test, as I indicated, finally Dr. D stated in the presence of all analysts, he was the head of the manager, the branch manager of the laboratory, and he stated in front of everybody, their colleagues were facing Dr. Santilli, brought to us what appears to be indeed a new chemical species, and he released a signed statement to that effect, which is reproduced in its original form in this 105 pages memoir. Since that time, we have done numerous repetitions of the same test. Here I report only one, 2012, by this group of analysts, also with the GCMS equipped with the infrared detector, and they obtain exactly the same results with MagneGas this time. Namely, there is a large number of peaks in the mass spectrum when you move from 40 up, And when you go to the infrared detector, you see only one signature, the CO2. This was confirmed a number of times. You can inspect this paper if you are interested. This test has been redone a number of times, and you can inspect this paper as well as the recent reference to see the situation in detail. The decisive method for the detection of MagneGas was, however, occurred only later, and it was finally identified by the Oneida Research Laboratories in New York, who have a very special method for the mass spectroscopy for gases that honestly I do not remember. I suggest a number of years have passed by now. I would recommend to go, in case some of you is interested, I would recommend to contact the OIRS laboratory. Actually, the website indicates this method. But the bottom line is the following, that method permits the identification of each and every species in a gas from 2 atomic mass units all the way to hundreds. So this way you have a detection of exist, and then for each atomic mass unit, the method identified the parts, how many, and that for each given atomic mass unit, the method identified the percentage in parts per million per volume, ppv. Again, this I would recommend to contact the laboratory for technical details. Here I show from 2 all the way to 48, I believe. But then we did this test at Oneida many, I don't remember, a couple dozens of times. Here we want to show you from 2 all the way to 48, from 48 to 90 and so on, and then finally to only 149, if I remember correctly. But in other tests, the MagneGas were detected all the way to 450 atomic mass unit. This is a case in which we had 4 different samples of MagneGases, and for all of them we had a similar, except one was heavier than the other one. But another anomaly, which is typical of MagneGases, is that the so-called hydrogen accretion. When you go to the higher mass spectrum, we are talking about 205. This scan initiates at 205. You see you see each and every peak for each and every one atomic mass unit: 205, 206, 207, 28, 209, all the way to 450. This can only be explained as due to hydrogen accretion. Namely, this is evidence, in my view, that the hydrogen is is polarized into a toroid, and therefore has indeed in its structure a magnetic field, and therefore that is then, as a result of which it is attracted by other species, similar species, resulting in a magnecular bond. I would like to pass now to a brief review of the chemical anomalies of the gases with a magnetic structure. With the word anomalies, I mean features that, to the best of my knowledge, cannot be quantitatively represented by quantum chemistry. So therefore, they constitute new chemical knowledge. And any critical comment, quantitative critical comment on this aspect will be appreciated indeed. From a scientific viewpoint, or at least as far as I'm concerned, those anomalies are the most exciting part of the entire project. But I regret to be unable to enter in any detail for each anomaly what are the fascinating possibilities and implications, which I have to leave at this moment to the imagination of individual interested colleagues. Let us begin with a review of what appears to be the most important and intriguing chemical analysis of magnecular fuel, and that is given by their anomalous flame temperature, which has been measured by the Institute for Ultra-Fast Spectroscopy of the City College of New York, with a full report available in the final list of reference with a free hyperlink for PDF download. The report carries the signature of the Institute Director, Professor Alfano. Here I present only a summary because of lack of time, but what is the bottom line? The bottom line is that this particular form of MagneGas produced from essentially from crude oil and water has a flame temperature which is about 3 times, flame temperature which is about 3 times the flame temperature of corresponding gases such as hydrogen, acetylene, methane, and so on. Another important chemical anomaly, which is of course directly related to the preceding one, is the chemical composition of the MagneGas exhaust. This is a chemical analysis released by Atlantic Analytic Laboratory with the signature of the director. And you can see the carbon monoxide, there is ND, non-detectable, in the exhaust of the MagneGas produced from fossil fuel. Carbon monoxide is not detectable. Ladies and gentlemen, this is the reason why I spend decades of my life for the study of the species, because I do care about our environment, particularly, and I am worried for what the environment we are leaving to my children and to my grandchildren, and on their face, at least I want to try my best. And now this feature was predicted since the beginning of the studies. Why so? Because carbon monoxide, as we all know, is combustible. Carbon monoxide released in the exhaust of our gasoline car is combustible. So why do we need a catalytic converter? We need a catalytic converter because the flame temperature or the combustion temperature of gasoline is not sufficient. If you convert gasoline, or at least the crude oil producing gasoline, plus water into a molecular fuel, then the combustion temperature becomes 3 times that of gasoline, and therefore, under such a high temperature, carbon monoxide cannot exist. Any detection of the contrary will be impossible. The same, another intriguing feature is that you look at, for instance, oxygen. There is anything from 6 to 12% of breathable oxygen in the exhaust. Now, these important findings are confirmed by this 4-way gas and exhaust car analyzer, which was calibrated and certified by the manufacturer. And this was attached to the exhaust of a car running on MagneGas synthesized from fossil fuel plus 25% of water. Again, we go and look at the CO, 0.00, CO is 0.00. And we look at CO2, 6%, and O2, 12.7, breathable oxygen, 12.7% breathable oxygen. What was not measured by the 4-way analyzer is that over 50% of the exhaust is made up of water vapor. Indeed, the same car, when used with the same gas, but in a cold winter night, the exhaust basically is a white smoke, which is the typical exhaust of the combustion of hydrogen into water. We are now sufficiently equipped to identify at least the most significant forms of fuel with molecular structure. They all have the same characteristics. Remember the liquid water at the boiling temperature? It ceases to exist, the liquid state, and there is a transformational state, in this case, into a gas. For the case of molecule, gas with molecular structure, we have a different but a similar transitional state. The only point that at the combustion temperature, any gas with a molecular structure is reduced to a collection of isolated atoms. Collection of isolated atoms at the Curie temperature of the molecular species. With this in mind, let's see a few of the most significant molecular fuel. that I found in my study. The first is aqua fuel, which was the first in which we detected the molecular structure. It is a fuel produced from, is a MagneGas produced from water. Then there is MagneGas, properly developed by the MagneGas Corporation, that which I did most of the studies, which is a molecular fuel produced from a fossil fuel, any type of fossil fuel, plus water, the minimum of 25% water to improve the environmental quality as well as the energy of the gas itself. Then there are two important gases which are called magne-hydrogen, magne-oxygen. Those are essentially the hydrogen and correspondingly the oxygen content on MagneGas, which can be separated from MagneGas by a conventional PSA, pressure swing adsorption equipment, commercially available in various countries. And finally, there is a very special fuel called that I call HHO, and which is essentially a combustible form of water. Unlike all preceding fuel with a molecular structure, this fuel is not produced by submerged electrodes, carbon electrodes. No, it's a totally carbon-free electrodes, which converts by a new equipment, converts water into this combination of air, hydrogen and oxygen, which is absolutely fascinating for me. Why? Because it cuts bricks at contact. It's something that has to be seen. The moment the flame touches a brick, the brick melts instantly. Unbelievable. The fuel has also unbelievable, incredible feature, such as it can cut metal underwater, of course, because there's no need of oxygen, as all the necessary oxygen for combustion, and other features which I regret to be unable to discuss for lack of time. But in each of this fuel, I quoted a reference with free PDF download, as well as as well as a monograph written for the general public, which describes them all, which is called a fuel with molecular structure. And here is the link for a free PDF download, while I remain available for any question by interested colleagues. Let me pass now to a brief indication of some of the most important applications of fuel with molecular structure, with sincere regret not to be able to list them all, and for not to be able to identify, to enter into detail for each of the application that I will indicate. The first applications of MagneGases that we developed was for the cutting of metal. Why so? Because of their incredible efficiency in metal cutting. Here we show a slab of 10 inches thick, 10 inches thick. It is cut like almost like a butter. Well, not in reality, but rather easily. Why so? Well, because at the moment of injecting the gas under combustion, the metal cut is invested by isolated atoms, hydrogen, carbon, and oxygen. Therefore, there are all sorts of anomalous chemical reactions that facilitate the penetration of the hydrogen deep into the structure, and therefore the rapidity of the cut. Incidentally, you should remember that the use of MagneGas for metal cutting has produced no carbon monoxide in the exhaust. No carbon monoxide in the exhaust. Therefore, can be safely used for metal cutting inside the ship. For instance, for shipbuilding, nowadays they use acetylene for metal cutting, but acetylene releases in the exhaust up to 3.5% poisonous, highly poisonous carbon monoxide. Therefore, the operator have to use very special respirator with oxygen assistance. If they use instead MagneGas, they can freely use it without any special breathing apparatus. Here I show a number of cars that I converted to operate on MagneGas and tested in comparison with the corresponding behavior with gasoline. Here I show an SUV, a Chevrolet Suburban, converted to operate on MagneGas, produced from all tests were done with MagneGas produced from fossil fuel, plus a varying percentage of water beginning from 25% on. Here there are two Hondas. Here is a Honda that was shipped to the racetrack in Monza, Italy, for test in the Monza track in comparison with other cars running on natural gas and other synthetic gases, with very intriguing results. If nothing else, this car had no catalytic converter. None of those cars had a catalytic converter because none of those cars had any carbon monoxide or other contaminants in the exhaust that are prohibited. No other contaminants that are prohibited by European or American regulation. Here I depicted Ferrari 308 GTSI, which I converted to MagneGas. The car was injected but turned into a carbureted car running on MagneGas. Here the car is depicted at the Moroso International Racetrack. We also tested the car at the Sebring, at the historical Sebring racetrack. In all those tests on tracks, the comparison was with the ordinary identical 308 GTSI, but running on gasoline. In all cases, the MagneGas car was more powerful, and above all, the engine would run much smoother because over 50% of MagneGas is composed not ordinary hydrogen, it's composed of magnehydrogen, which are a very high number of octane. And so the smoothness of the behavior was such that we had to put a limit on the RPM at 8,000 RPM, because otherwise the piston would essentially come out of the engine, because there was no limit that we could normally the engine would normally take for as far as the high RPM is concerned. On the right hand side here is the car that I was using every day when I was working at MagneGas Corporation. Is a Chevrolet Cavalier. Stock, totally stock car, no change whatsoever, none. It was produced to run on natural gas. I will, instead of natural gas, I will fill it up instead with MagneGas, indicated above, synthesized from fossil fuel plus 25% alcohol, and essentially I will refuel the car. With our own fuel. There was no need for me to go to the gas station. This car as well had no catalytic converter, yet it was surpassing all EPA requirements. I would like to present now the possible application of magne-hydrogen and magne-oxygen to the aerospace industry, specifically as rocket fuels. I regret not to have the necessary time to enter into technical details, but I remain available via email or via Zoom session to any interested colleague to discuss this intriguing possibility in more details. I present here 3 papers out of a considerable number of papers in the field. The first one is a paper in which I presented, apparently for the first time, to new species following chemical analysis done in the US laboratory who identified anomalies, deviation from the prediction of quantum chemistry. The remaining 2 papers that I list, the second is an experimental confirmation at an analytic laboratory in Atlanta, Georgia, and the third is a full-fledged confirmation of the entire content of paper 1, done by gas chromatography, mass spectroscopy, equipped with the infrared detector. Now I should indicate that by no means those 3 experimental papers are sufficient. No way, as evidently you will see soon. But nevertheless, Nevertheless, they identify with certainty the existence of the anomalous character of those two species. The feature which I would like to bring to your attention, in this case specifically for MagneHydrogen, are the following. The first and the most important for me from an environmental viewpoint is that MagneHydrogen does not seep through the wall of the containers, so therefore can be stored long term. Besides the resolution of this long-term storage problem for hydrogen, then there is also an environmental then there is also the resolution of an environmental problem that is indeed in my heart, and that is the seepage of ordinary hydrogen through containers wall raises virtually instantly to the ozone layer due to since the hydrogen molecule is the lightest molecule on Earth and once you reach the ozone layer, it has an extremely fast chemical reaction with O3 by therefore depleting the ozone. And it appears that this environmental problem can indeed be solved by MagneHydrogen. The second feature that I would like to bring to your attention is that the increased specific weight of MagneHydrogen. This is due to the hydrogen accretion, which I have indicated before, and according to rather numerous chemical analysis, in which the specific weight of MagneHydrogen is a multiple of the specific weight of the hydrogen. Now, this I believe this should be considered by the aerospace industry. Why? Because this feature implies a reduction of the size of the tanks in a rocket. I repeat, the increased specific weight of hydrogen implies a reduction of the size of the tanks of the rockets, that therefore should be of some interest to the aerospace industry. The third feature that I would like to bring to your attention is the increased energy output. This is also clearly due to the fact that at the Curie temperature, which in the case of MagneHydrogen is the combustion temperature, then MagneHydrogen reduces to the individual hydrogen atom, by therefore avoiding completely the loss of energy that is necessary for a rocket to combust hydrogen, because prior to the combustion, there is the need of dissociating the hydrogen molecule, and such a dissociation is quite expensive, talking about 110,000 kilocalories per mole. The next feature I would like to bring to the attention of is that the prediction of a bigger liquefaction temperature on grounds that the molecule composing MagneHydrogen are technically can be considered as indeed liquid, also due to their increase with the pressure. And finally, I would like to bring to your attention the increased chemical reactivity of MagneHydrogen as compared to that of conventional molecular hydrogen, which makes this species interesting for a number of other applications I cannot indicate in this lecture. I would like to close this lecture by indicating how intriguing are the open problem of this new field of chemistry. And for instance, there is the prediction that Avogadro number is not conserved for species with a molecular structure. I repeat, there is a prediction that Avogadro number, of course, is a constant for molecular species. But for the case of the molecular species, then there is a prediction that the number will change, will either increase or decrease, depending on the various individual specification under consideration. This prediction can be easily tested, but by using a simple PVC apparatus and with a sample of MagneGas or MagneHydrogen, and I hope it may be of some interest to all of you. Thank you for your attention.